Hello everyone, we will now look at a question involving quadratic equation. Basically, for this question is about projectile motion. We are told that an object is projected upwards from a mini launcher with an initial speed of 12 meter per second. Uh, Initial speed is also denoted by this symbol U. Okay, is height h and the time is t seconds. So there's an equation given to us, and the equation given is h equals to u, which is 12, and then we have a, which is given as negative 10 t square plus 8. So basically we are told that the height equation can be simplified into negative 5t square plus 12t plus 8. Okay, so this is the equation given to us. And for part 1, we are asked to explain the meaning of the constant term 8. So basically, the constant term happens when the time equals to 0. So when time equals 0, it means that at the start, okay, of this particular motion, the object, or rather this object is at 8 meters, okay, and we are told that the height is just measured, okay, relative to the ground probably. So for part A, we're just gonna say that 8 is the distance, or the original distance of the object at the initial point, or rather at the start of this particular motion. Okay, for part 2, find the greatest height. So basically, for this equation, if we were to sketch a graph, okay, of height against time, okay, this object started out at 8 meters, right, before it even started to move upwards. Okay, and then this object will continue to move up, and then it will come back down. So for part 2, the question is asking us to find out what is the greatest height, okay, as well as what's the time in which it occurred. So basically find out what is the coordinate, okay, of the point that is labeled in red. So what we can do is to find the turning point, okay, we can find the time first. Okay, so the time that we want to calculate, okay, there's a shortcut that we can use, which is t, okay, is equals to negative b over 2a, okay, where the b value is 12, so negative 12, okay, over 2 times negative 5, okay, and the time at which this happened is at 1.2 seconds. So at 1.2 seconds, this object will reach the greatest height. Okay, and when the time is at 1.2, we can find what is the greatest height as well. So by replacing 1.2 into t, so negative 5 bracket 1.2 square plus 12 bracket 1.2 plus 8. Okay, and then we will get the corresponding height as well. Okay, so calculating this value, okay, we can just use our calculator, okay, and we will get the answer of 15.2 meters. All right, next, for part 3, when will the object be 14 meters above the ground? So basically, we know that the maximum height, okay, is 15.2 meters, and this happened when the time was at 1.2 seconds. So at which instance will this object be above 14 meters? So above 14 meters is probably, okay, at this point that is marked out in green, okay, and another point as well, okay, which is also marked out in green. So basically we are trying to find out what is the interval of the duration, okay, and that is shown, okay, when the object is moving along the green colored path, okay, in the or along the curve. So basically for part 3, we are going to let the height, okay, be 14, and then we are going to solve for the time. So what we can do is we can take 14 equals to negative 5t square plus 12t plus 8, okay, and then we can move all the terms to one side, okay, and solve for t. So I'm going to move everything to the left hand side. So 5t minus 12t plus 6 equals to 0, okay, and then I will use the calculator, the shortcut in the calculator, to help me to find out what is the value of time quickly. Okay, in fact, using the calculator is much faster. So the first amount of time, or the first time where it happens, okay, is at 1.69 seconds, okay, and the second time in which it happens is 0.710 seconds. So there are two instances in which this object, okay, is at 14 meters above the ground. So what we are going to do is we will have two values here. Okay, why we have two values is because there are two instances. Okay, the first instance is when the object is moving upwards, and then the second instance is when it's moving downwards. So during the interval 0.710 seconds to 1.69 seconds, the object is above 14 meters. So this is a quadratic equation. Therefore, we can have a maximum of two solutions. Okay, and then the minimum number of solution is of course 0. Okay, so if the object will never reach 16 meters, for example, so that is a 0 solution. All right, thank you for watching this video.